Okay, let me give you guys an example. So here, sketch this function here. So when you come to sketch this function here, you consider what happens when x is really, really big around this region, and when x is really, really negatively big around this region here. So visualize this as one block, taking away this block, taking away this block. So try and visualize this graph here. If you visualize this graph here, it would look like this. Okay, it will look like this, and then try and visualize this graph here. So when you come to visualize this graph, it will look like this. It will look like this because hang on because so when you try and sketch this here, start out with your function e to the x. So you've got a function f of x equals e to the x. Okay, so start out with this. So that will look something like this, and then apply this transformation. So that will then give us this here. But remember, we're trying to sketch this graph here. So start out with this. Apply this transformation here. So when you apply this transformation, it flips it along the y-axis. So it will look something like this. So it's a reflection along the y-axis. So now you've got a -2. So okay, so apply this transformation. Apply this transformation. Hang on. Apply this transformation. This transformation. So this here we say that, well, take the negative version of the previous thing. So it means take the negative version of the previous thing, being this. So this will then give you minus e to the minus x. So when you apply this transformation, it flips this thing upside down. So after applying this transformation, it will then do this. Okay, and then because you've got a 2 in front of it, it will be a lot steeper. So it will look something like this. So overall, it will look something like this, roughly. Okay, and then now visualize this. So that 3x normally is quite steep, but on this scale here, visualize the 3x as being something like this. It's actually quite shallow in comparison to this. Okay, around here is quite well. A graph of 3x here is actually when x is big, it's actually very shallow in comparison to this. Okay, so when you now that you've got the 3 graphs, you've got 3x looking something like this. Now that you've got the 3 graphs here, 1, 2, 3 here, consider what happens when x is very, very big. You see, looking at the original one, looking at the original function, you've got this, take away this, take away this. You see, when x is big around this region here, this term here dominates. These two you can pretty much forget about. Okay, this term here will dominate in this region here when x is very, very big, because look at this, you've got e to the power of x, which is massive up here, plus, well, minusing something very, very small, minusing something tiny. If you look at this here, this is tiny. Okay, so you've got this thing here, which is very, 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 very big. Okay, take away something taking away something small, and then taking away something that's very, 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 very small. So we can pretty much ignore these small bits and just concentrate on this. So the point I'm trying to make is that when x is very, very big, this thing here will dominate. E to the power of x will dominate. So your graph will look something like this. Around this region here, it will do this. So we're going to guess it to be, well, it's going to do something like this. Okay, that graph looks something like that. So we're going to guess it will do something like this when x is big. Okay, now consider what happens when x is small. So consider what happens when x is negatively big, but yeah, negatively big around this region here. So you've got this, take away this, take away this. Now let's look at the 3 graphs. Hang on. So we are considering what happens when it's around this region here. Okay, when x is big, negatively big. So our 3x is pretty shallow in comparison. Okay, so our 3x looks something like this. Well, when in this region here, you look at this term here will dominate, because this term e to the power of x around this region here is very small. Look at it, it's tiny around here. It's tiny. It's around this region here. It is tiny. That bit there is tiny, and 3x. It is okay. It's still quite small in comparison to this. You see, around this region here, around this region here, this thing here will dominate. Look at this. Around this region here, you've got something that's really big. From here all the way here, and then you've got to take these two into account. This is next to nothing. This is pretty next to nothing as well. So this term here dominates. So it's like me saying minus 999 of something very big, and then you've got to take something into something very small into account, 0.0000 whatever 1 here, and then this is going to be tiny in comparison to this. My point is that around this region here, this term here will dominate. Okay, so so it wants to do this thing here when x is negatively big. It wants to do this thing here. So your graph will look something like this. So when it's big around this region, it wants to do this. So it would do something like this. Okay, this being 1, and then when you're around this region here, it wants to do this. So it wants to do that. So maybe it's a lot steeper than this one. So it wants to do this. Okay, and then now consider what happens when. So your graph will look something like this. Your graph will look something like this. Okay, but then consider what happens when x is 0. You see, if you put 0 into here, and then put 0 into here, this thing here will become 1. This thing here will become 1 times 2. So that will be minus 2. This thing here will be 0. So minus 0. So we know the intercept will be 1 take away 2. That will be minus 1. So we know the graph is going to do something like this. When it's big, when it's negatively big, it wants to do something like this. So, but it has to go through here. So let's just guess it to be something like this. So the next video, we're going to consider the critical points. Find out where along this line it will be 0, where the gradient will be 0. Okay, but so far our graph will look something like this. Okay.